We're going to be talking about how to build the top 5 techniques to build the worst microservice system ever. I really like this image as a representation of microservices because you've got this gentleman on a scooter. It's a bit washed out in the projector, but he's going really fast and he's not hampered by any bloat like protective headgear or anything. And his center of gravity is really high and the pivot point is really low, and all it takes is one bump in the ground and permanent brain damage. Just like microservices. So who am I and why am I qualified to talk to you about microservices? My name is William Brander. I'm from South Africa. I know the South African accent can be a little bit difficult to understand at times, so I will try and enunciate a little bit clearer than I usually do, and I will try to speak a little bit slower than I usually do. Hopefully that helps. As you can see from the mug, I'm the world's okayest programmer. I'm also incredibly passionate about building bad systems. I hope some of that passion is going to come through and energize the room so that we can end the day on a high note. There are 3 things that I dislike about this mug. The first is that the A in programmer is tilted ever so slightly to the side, just enough to bother my OCD. The second is that the font is dangerously close to Comic Sans without actually being Comic Sans, because that would be sort of cool in an ironic way. But this isn't. It's just like a weird knockoff. And then the third is that the mug is unfortunately unverified. It may surprise you to learn that there was not, in fact, a worldwide census done on developer ability with me landing square in the middle. So I went about looking to see if there's other ways that I could prove that I was an okay programmer. And I spent some time looking through my company Slack. And my coworkers definitely don't think I'm the best programmer either. But at least one of them doesn't think I'm the worst. So I've got that going for me. But what does being an okay programmer have to do with writing bad systems? Right? Being an okay programmer means that I've probably written some systems that I'm proud of and some that I'm a little bit ashamed of. But I'm sure everyone has written some bad system, right? Has anyone not written a bad system before? If anyone's hiring, look around for hands now. We've all written some bad systems. So what do I bring to the table that can elevate me and can really make it that I'm the guy to teach you how to write bad systems? Well, that's got to do with who I work for. I work for a company called Particular Software. We make N-Service Bus. Has anybody heard of Particular? Well, we've got a booth outside, so if you haven't heard of us, we've done a really bad job. Anybody heard of N-Service Bus? I hope everyone. Anybody using N-Service Bus? Thanks for my salary. So for those of you who don't know, N-Service Bus is a library and framework for building distributed systems. So whether you want to build microservices or SOA or just partition your system, N-Service Bus can help you do that. But that's not what this talk is about. So what does working for Particular have to do with making bad systems? Well, at Particular, if you work on the engineering team, you also do support. There's no distinction between engineering and support, which means that if you work on N-Service Bus, you support N-Service Bus, and you support the customers that use N-Service Bus. And that's honestly one of the more fun things that I get to do is support, because I get to see a lot of different systems applied in a lot of different ways at a lot of different scales, and I get to see how people are using N-Service Bus to build these distributed systems. But here's the thing about support. If one were to assume that system quality follows a normal distribution, where you've got some really poor quality systems on the one side and a few really high quality systems on the other side, with most systems having reasonable quality sort of in the middle, that doesn't really help with support, because the people that have got the high quality systems aren't coming to support for help, and the people that have got the medium quality systems aren't coming either, because they can probably work out their problems themselves. So the types of systems that I see when I do support are the ones down here. And I see a lot of these. In fact, as far as I'm concerned, based on my history with support, it means that the distribution of system quality does not follow a normal distribution like this. As far as I'm concerned, all systems are bad, and as an industry, we should be ashamed of ourselves for what we're doing to our poor customers. So microservices, right? Why do we do microservices? The consulting answer for why we do microservices is we want to decrease coupling so we can have independent deployability. We can scale things up and down without bothering the rest of the system, and blah, 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 blah. Nobody does microservices for that. We do microservices so that we can increase complexity and decrease performance. We do microservices so that we can come up with the most convoluted way to render angle brackets for a browser. And most importantly, we do microservices because we don't want to be seen to be doing a monolith, right? Monoliths are bad. If you start a project and say, well, I'm going to start with a monolith architecture, You get looks of despair from your colleagues. Every new project it's going to be a microservice architecture, right? Monoliths aren't bad, though. They're good. This picture on the left-hand side is of the Kailash temple in India. It's carved from a single rock, making this the largest man-made monolith in the world. The ERP system you've been working on for the last 7 years doesn't come close. Here's a different picture of it with a slightly better angle. You can see there's people on the, probably in the way there, there's people on the side on the left to give you an idea of the scale of this. This is huge. This is a massive undertaking. They carved this from hand. Well, I mean, not from hand. They didn't claw the rock away. They had tools, but they weren't electric or pneumatic tools. This must have taken an immense amount of planning, dedication, work, effort. This has been a labor of love for someone, and a whole bunch of slaves, probably. But it's beautiful. Monoliths can be beautiful. Don't think you have to do microservices because the alternative is monolith. There's a spectrum and a whole lot of options in between. As a side note, could you imagine what this would have looked like if they had built this using Scrum? So, for the rest of the talk, I'm going to assume that we have a system, and we're now trying to transition the system into microservices and make it as bad as possible. And we're going to see a few techniques that we can do with that. So we've got a monolith. It's a monolith, so it must be bad. So it's a tire fire of a monolith. And we're going to transition this to microservices. And a typical technique, and it's come up a few times at the conference already, is to apply something known as the strangler fig pattern, where you take a bit of functionality in your system, say the charge credit card method, you isolate that from the rest of your code, and then you move that off to a service. And then your main monolith can call the new service instead of having to have that call in process. Yay, we've microserviced. What have we actually done, though, to our system? So if we apply this everywhere, what is the result? Well, let's take a look at the throughput of the system and how the throughput changes as the load on the system changes. We'll start with the monolith. So as the load of the monolith increases, the throughput will increase as well. At the start, it'll increase fairly linearly. And by that, I don't mean one-to-one, but there'll be some like K factor where as the load increases by 1, the throughput will increase by a point somewhere between 0 and 1. Hopefully not 0. And as the load increases even more, that throughput should increase a little more as well. But the rate of change of increase will decrease a little bit because as the system is doing more things concurrently, there's more handing over to different threads, there's more exchanges, you're waiting for resources. So it will start to taper off a bit. And eventually it's going to get to a point where the throughput is going to drop off completely. And you might ask yourself, well, why? What is the behavior that's causing this to happen? And this has got to do with the way that .NET does memory management. So in .NET, there's 3 types of garbage collection events: generation 0, generation 1, and generation 2. Technically, there's also generation 3 or large object heap, but for the purposes of this discussion, we can fold that into generation 2. And the way that garbage collection works is that when you try and allocate a memory in .NET, if there's certain criteria met, .NET goes and says, okay, I need to free up some memory. Let me go and do a Gen 0 garbage collection event. And a Gen 0 garbage collection event is intended to clear up resources that have been allocated and freed fairly quickly. So var x in a function, var x equals ABC. And then the function finishes, the garbage collector can retrieve that memory and return it back to the pool. But if the garbage collector tries to retrieve or tries to free up a bit of memory in Gen 0 and it can't, it promotes that to generation 1. So generation 1 is intended to be for longer-lived variables, a longer-lived memory. Perhaps it's a variable on a class, and the class sits around for a bit longer and does a few other things. If a generation 1 garbage collection event runs, and it can't clear up memory because something's still referencing that object, it promotes it to generation 2. And that's where the problem happens. So generation 2 in .NET is a stop-the-world event, where as a generation 2 garbage collection event starts, all user threads are paused in your app domain, which means except for the thread doing the garbage collection. So all of your other threads will pause. And many years ago, Stack Overflow experienced this, and Mark Gravel wrote a blog post explaining why this happened and what they were trying to do to work around it. These 3 big spikes over here are increases in response time because the Gen 2 garbage collection event was pausing all user threads in the application. So the performance at these points was very, very poor. It's gotten a lot better since then. After this came out, we got the concurrent garbage collection configuration. and now that's been replaced with the background garbage collection configuration, which doesn't, it interleaves some of the garbage collection for Gen 2, and it more proactively gets Gen 1 and Gen 0 garbage collection done. So Gen 2 garbage collection now pauses and then resumes a little bit, and then the garbage collection carries on a different thread a little bit later, so the pausing is sort of split out. It's still a horrible experience when you're dealing with performance. But that's our monolith. Our microservice is better now, right? So what happens when our microservice experiences load? As the load increases, the throughput will increase. The throughput will also increase at a fairly linear rate, but it will increase lower than the monolith because you've introduced a network hop. Network operations are expensive, which means that these threads that are doing the processing are probably going to hang around a little bit longer. So there's going to be more contention for resources, which means that flattening off is going to come sooner. And because they're hanging around even longer, there's more chance that they're going to be promoted to generation 2, which means that drop-off is going to come even sooner. So by simply distributing our system, we could have potentially made the overall throughput of the system worse. The first rule of distributed computing is don't distribute your computing. But we've gone ahead and done this, and we've potentially made the throughput of our system worse. This isn't always true. For instance, if the charge credit card method was on the hot path and we isolated this and moved this off, we could then scale that hardware up independently. But we're not going to do that. We're just going to microservice the way we learned at the conference, so we're going to do everything on one machine anyway. So the first technique we can use to mess your systems up is to put an HTTP call in front of everything. Who here remembers when .NET 3 came out with WCF? Right, yeah? There were those people going around, everything should be a WCF class, operation contracted all. It's a great idea. That was a very weird time. There was WCF, WPF, Workflow Foundation, and card spaces. And card spaces just sort of disappeared very quickly on in the evolution of .NET there. Okay, so we've taken our monolith and we've strangle-figged it until it's no longer a monolith, and now it's distributed. We still have the same coupling between the components. We still have all the same problems we had before. We've now just made the performance lower. So it's still a monolith, it's just distributed. That means instead of a problem that we have with our monolith, working with our monolith, we've now got to also introduce network topology coupling to that. So that's another layer of coupling that we've put in there. So it's not just a tire fire, it's a burning field of tires. This is a good first step. But this is difficult for us to work on. This isn't a pleasant experience. And we don't want to make our lives worse. We just want to make the system worse, right? We want to enjoy our job. So we go to business and we say, I bet you I can rewrite the system in 6 months. Anybody find themselves thinking that? I've done it many times, that particular. I've even tried a few times. Failed miserably. The thing with big bang rewrites is that they don't work. Little asterisks in the air, they work in 2 specific scenarios, which I'll get to later. But why don't they work? Why do big bang rewrites of large complex systems fail? And that's got to do with how software works for these large systems. So as you're developing the system, we'll have another graph here. Where on the y-axis, we've got the functionality that's available in the system, the amount of features that we've got. And on the x-axis, we've got the time that we spent developing the system. And at the start of the system, as you start developing, it's fairly easy to add new functionality because you don't have competing components with each other. You're still getting to know all the business rules that you have to work through. You know, it's a nice time to work. This is the greenfields area. We all love greenfields projects, right? As we carry on working, though, the rate at which we can add new features decreases because we have to add features where we didn't really design the architecture to match that feature set at the beginning. So it's a little bit slower to add the features. We have to change a few things and propagate. And there's competing business rules that we have to worry about. But that's fine. And then eventually it gets to a point where adding any bit of functionality takes a lot of time and effort. Potentially even just changing the name of a field on a form could be a full sprint process to do sometimes. So let's assume that at this point here, this is where we went to business after we've done our distributed monolith, and we said, please can we have 6 months to do a rewrite? After we've done the rewrite, everything will be wonderful. The UI will be modern, the performance will be better, and we'll be able to add features before you even know what to ask for. It'll be so good. And business says, well, okay, 6 months. I'll give you 6 months to do this. And you're ecstatic, because now you get to do new work again, and it's great. So now, instead of working on the old system for those 6 months, we work on the new system. So we're not adding new functionality over this period. So this little section here that we would have added a little bit of value to our users no longer exists. That disappears. And instead, we start working on the rewrite of our system. And at the start of our system in the rewrite, it's really quick to add features, probably even quicker than when the first system started, because now we've got better ideas. We've been thinking about how we would improve it for a few months before we did the rewrite. We know more about the business domain. Things are looking great here. But it's not going to take 6 months. How do I know it's not going to take 6 months? Well, that's because I'm a developer, and developers are really, really bad at estimating. In fact, instead of doing coding assessments when you try to hire someone, they should do estimation assessments. And anyone who's really bad at estimating must be an amazing developer. Anyone who's really good at developing is probably really good at estimating is probably a project manager and shouldn't be developing. I myself am the world's okayest estimator. But even if you could estimate correctly, you're still not going to take 6 months. Even if your estimation for what you think the system is going to take 6 months is 100% accurate, it's still not going to be correct. Because developers are also a bit like that dog from Up, where you get distracted by a squirrel and you run off. The systems that we work on, it's very, very unlikely that any large system that we work on will be 100% documented. Even if it is, there's even less chance that we'll have all of that knowledge sitting in our head while we're trying to thumbsuck an estimate. It's going to be very difficult to be able to get those guesses right. So we carry on working, we do our rewrite, 6 months comes and goes, and it's now 9 months, and business comes to us and says, listen, we can't go on like this. We need new features. We've got a compliance deadline we have to meet. GDPR 2.0 or something. The return. So you start panicking, and your team starts working weekends, working nights. You order pizzas every evening for the team. You've got a masseuse coming in to massage the team to relieve stress and tension. And you're just driving morale into the ground. And eventually, you're still not going to be done, and business is going to come to you at a point and say, we can't do this. You've got to cut this rewrite. And you panic a bit. You panic because now you've put a lot of effort into the new system. You love it. You're emotionally attached to this new design that you've got. So you compromise, and you say, OK, business, I'll tell you what. Got an idea. We've still got the old system that's running in production, right? So we'll have that, and then we'll also deploy the parts of the functionality that we've currently written, or that we've rewritten. And then the users can use the new system for the stuff we've rewritten, and then for the ones that we haven't done yet, they can use the old system, right? But now we need to keep them up to date, so OK, no problem. We'll put an integration layer between the two, and then everything will be fine. Except we know that the integration layer is going to suck because the original system sucked. And the longer that this integration layer sits in production that we have to maintain and fix, the more chance there is of some of the bad elements from the old system bleeding over into the new system. Because there's going to be time pressure. You're going to say, oh, I need to get this field into a report. I'm just going to copy it in the same way that it is in the old system. It happens. But anyway, we're going to do this, so we're going to have 3 systems that we have to maintain, but at least now we can add new functionality for our users so we can meet those compliance deadlines or whatever. Once we've added that functionality, we can go back and carry on with the migration, right? I'm sure business will give us time then. They will, right? Please, someone. They won't. Well, they might give you a little bit, but you'll have to scramble for it, and that original system is going to live much longer than you ever thought possible. It's a bit like trying to build an aeroplane while you're flying it. I asked Stable Diffusion to generate an image of an airplane flying while you're building it, and I've got to say, this is also a really good description of microservices. It's terrifying. So now that after we've done our distribution of everything, the second thing that we can do to make our system worse is to attempt to do a big bang rewrite. I said there were 2 cases where a big bang rewrite works. The first is if the system is actually small enough to be rewritten in a reasonable time frame. This is tricky, though, because developers suck at estimating. So how do you know that it's small enough? Maybe it is, maybe it isn't. I don't know, it's unlikely. It's also, you kind of have to take into consideration that working on an old system that you want to rewrite is unpleasant. It's emotional, so it's hard for you to be objective about how long it will take to actually do a rewrite. So the first time it works is if the system is small. The second time that it will work is for your CV. So you start the rewrite, and you do the rewrite in the most amazing technology possible, and then a month after you've started working on it, you go for interviews and leave. It works for you, not for the project, but that's fine. So this is what we've got now. We've got 3 systems we're maintaining, and the longer that these systems are in production, the more of the suckiness we've got from the first system bleeding over into our new system as well. Let's make it worse. We don't want to be malicious about it, though. So remember this situation where we had the drop-off in performance because of long-lived calls waiting for responses? We don't want to do that in the new system, right? We want to accidentally make bad systems, not purposefully make them. So instead of service A calling the credit card service, because it's just going to wait around for a response and the same problem is going to happen, what we'll do is we'll introduce a queue. And then service A can put a message on the queue to say, charge this person's credit card. And once that message is on the queue, service A can end its call and terminate. And then we're done, right? That means that service A is less likely to live long enough to get promoted to Gen 2, so we've solved that problem. And everything's fine. We then go to our credit card service, which takes a message off the queue, calls Swift, or whatever payment provider we want to use, and everything's fine. Okay, cool. Except now our message gets to the front of the queue, and this message says, charge William's credit card £50. Cool. As we do that call, though, something goes wrong. The network fails somewhere along the line. Swift fails for whatever reason. Something happens. Okay, but we haven't actually charged William's credit card yet, but that's fine. The message is gone. Well, that's no good. We've lost money for our customers, right? That's a financial operation that we don't want to lose for them. So we suddenly think, okay, what we'll do is when we take the message off the queue, we'll process it in a loop. And in that loop, we'll put a try-catch. So if something goes wrong, we'll just keep processing it, and that'll be fine. And then we call Swift, and then something goes wrong, and maybe something's wrong on Swift's side, and they have to reboot some service internally, whatever it is. And they come to us and say, you're DDoSing us, guys. Whenever something goes wrong, you're just calling us nonstop. You need to back off. So you go back and you introduce some sort of timer mechanism, and you say, well, okay, each message can only be processed 5 times every minute. Yes, perfect. And then that goes into production, and Swift is at least happy with you there. But then you get someone like William who puts his credit card details in incorrectly on purpose because he doesn't want to pay £50. And then the message will never actually get processed because that's an invalid credit card number. Or maybe there's a bug in the code upstream that generated that message and that failed. But now that message is sitting at the front of the queue and everything behind it isn't getting processed. And you're like, well, okay, I know what we'll do. We'll introduce a dead letter queue, and then we'll take that message, move it to the dead letter queue. Oh, and don't worry, we'll also make software to manage the dead letter queue. And this is a really cool bit of architectural kit. This is fun to work with. And you're living for this framework that you're making. But it is a framework that you're making. And in this case, this type of problem is solved by Poly, NService Bus, Mass Transit, Rebus, Brighter Command. There's many options in the .NET space that will handle this problem for you. But instead of doing that, you're getting a lot of joy out of working on this framework. You might even open source it one day. That moment when you get your first star in your open source GitHub project, it's, oh. So the next technique we're going to use is we're going to make sure that we suffer heavily from not invented here syndrome. And every framework that we come across, we say, no, we don't want to use that because it doesn't 100% meet our requirements. We're going to make our own one. And that's how we ended up with so many JavaScript front-end frameworks a few years ago. But we're going to keep doing this. Because honestly, when you've got a system like this, some of the only joy you can get is working on cool engineering problems. And you're not going to get that from business problems usually. So we've got our monolith. We've got our new system that we're busy maintaining. We've got our integration layer between the two. And then we've got this really cool framework that we're working on. At least one, try for many. I highly recommend it. And at this point, we're basically not delivering any business functionality at all anyway. We're having a lot of fun on our custom stuff, but not really doing much for the business. So they're going to come to us and say, listen, we need the search screen that you've been promising us for months. Please, can you give us a search screen? And you think, fine. We'll do it. We've got a product service. And maybe they're an e-commerce site. They're Amazon, no, rainforest.com. So they're rainforest.com, And you can search for product, or that you can purchase products off of rainforest.com. And you've designed your product service to match this requirement. So you've got, for instance, the name of a product. You've got the price of the product. There's images for it, whether it's in stock somewhere, description, the rating of the product, fairly standard product-y things. We've all seen these types of things before. And you come up with a class and a data structure that sort of represents this, which looks a bit like this. All those fields, except it's got an ID. Yay, computer science. And based off of this, you can go and implement the customer's search screen that they wanted. So you can, in your product service, have a little search API, pass in a text string, and we'll search the name and the description and spit back all of the products that match. And you pat yourself on the back, and you go back to work on your framework now that business is satisfied. But then they come to you and they say, I've got an idea. The correct response when business comes to you and says, I've got an idea, is for you to excuse yourself from the room, say you want to get a coffee or something quickly, leave the building, get in your car and go home and pretend it never happened. But you don't do that. So business says, I've got an idea. We have a theory that, especially on consumable items, if someone has ordered a product before, there's a higher likelihood that they'll order the same product again. So can we maybe have a little field that shows, hey, you've ordered this before on the search screen? And you pause what you're doing on your cool framework and you swing over in your chair and you kind of just look incredulously at this person that's asked you the most obscene question ever, because the order status is not in the product service. That's in the order service. That's a very different thing. But you want to get back to working on the cool stuff as quickly as possible, so you make them promise that this is the only time they're going to do this. You even pinky promise with them. And they agree. They pinky promise and promise to name their firstborn child after you as well. So you say, okay, fine. So the product service, once we get the request, we'll also then call off into the order service just this once, and we'll go back to doing the cool stuff again. I mean, this isn't pretty. You've made your search screen slow because now your product service has to first query its database, then query another service, then put all the stuff together. But it's just once, it's fine, right? Then business comes to you and says, hey, I've got an idea. Remember the correct response? Leave the room, leave the building, get in your car, go home. Denial, denial, denial. We want to reward our gold customers and give them a 10% discount. So special pricing per customer, please. And I mean, at this point, you may as well give up because they're going to come and ask for every single service in your system anyway. So the customer status doesn't sit in the order service. It doesn't sit in the product service. It sits in the customer service. So we're just going to start chaining all of these calls together. And eventually, we're going to end up with dedicated teams that can manage our API gateways. Has anybody worked with in an environment where there's a dedicated data-powered team and only they can make changes to your API gateway? It happens. These API gateways can solve these problems for you, but they can become they are another layer of coupling that you introduce into your system. A new set of technology you have to worry about. Has anyone seen this video? If you haven't, do it. It's called Microservices on YouTube by a channel called Krazam. It is the best description of this type of thing ever. The man's face is like a mirror image of me in business meetings sometimes. Why did we end up like this, though? I mean, we've got a product service. It's nice. It's concrete. It's very neatly encapsulated. We've got an order service, a customer service. Look at these classes. These are beautiful. Why is this not working for us? And the reason is that people don't interact with products on your service. They don't productize things. They don't producty. They search for things. They perform operations in your system. They don't perform things. Even if your user is busy updating your product catalog, they're still not producting. They are updating a product in your catalog. And having the idea that a product service, a thing service, is going to neatly encapsulate and not bleed over into other boundaries is a bit weird. It's like when you do a search on a screen, it's like a puzzle that you build, and you take pieces from different places and you put them together to make the whole puzzle. Although I've actually just realized the puzzle is a really bad metaphor for this because it's always got the same pieces in the same places. But think of something like that, right? You're taking information from different places and you're putting it together to build one experience for someone. The thing is, people interact with your system by doing things, not by objecting. So the next technique that we can use is when we define our service boundaries, we can make sure that they are designed based off of nouns and not verbs. Anybody working in insurance? This is a big one that I see very often in insurance space. You don't have to put your hand up if you are doing this, but if you've got a claim service or policy service, you know, usually that's a bit of a red flag and something to look at. People, well, I suppose claims might work sometimes because you do submit a claim, but people don't policy. They do a quotation. They go through the order process. Their underwriting is a process. They don't policy. Okay, so we've got our three systems, our monolith, our integration layer, our new system. We've got this cool framework that we're working on as well, and we've made sure that when we defined our service boundaries, they're all based on nouns so that we can maximize the chance of having cross-communication service calls between everything. We're building another great monolith on that side. Let's see if we can make this even worse by trying to make it better, right? So we'll go back to that search screen. Well, we don't want this, right? This is bad. Let's see if we can improve it. What we'll do is we'll introduce a new service, a search service. To search is a verb. We're doing something, right? Yay, we're learning. The search service will be a dedicated service only responsible for searching. So it won't have a product class. It will have a search product class, which has a couple new fields on it. And if we need to change the business rules in the search service, we can update that, right? Sounds reasonable. How do we get the data into the search service? Well, that's easy. We'll pub sub it, right? So what we'll do is we'll tell the product service, hey, whenever you update your product list, publish an event for us, please. And then I'll maintain a search catalog and I'll update that whenever the product list changes. Okay, and whenever the customer status changes, also publish an event, and then the search service can update its list. And we can do the same for the order service. This is an awful lot of data duplication. We've got things in different places, but we're smart, we're engineers. We can explain this away, right? The source of truth, if you use that phrase, it's clever, the source of truth of the products is in the product service. Right? What we've got in the search service is it's a different model. It's a, what can we call it? A read model. That's right. We're doing a projection. This is CQRS. Yay! And we're using pub sub, right? So there's events. So it's CQRS and event sourcing and services, domains. We're doing DDD CQRS event sourcing. This is a good system design. Go technology. We still have the same coupling problems here. If the customer service changes the way that it rewards customers, that has to flow through into the search service as well. For instance, if the customer service says instead of rewarding discounts based on status, we want to reward the top 100 customers. Our top 100 customers will get 50% off. The next 200 get 10%, and then the rest just get an extra 10% added on because we want to help them monetize their way up into the stream, right? We make that change in the customer service. We then have to make that same change in the search service because now the search service doesn't have statuses that we have to worry about. That coupling still exists. We haven't hidden it away. And the thing to remember here is that even though it looks like it's separate and it looks like it's decoupled, the view isn't the same. So the logical boundaries and the deployment boundaries, or the physical boundaries, are different. And we've treated it as if they're the same. If we have a search service and it's deployed separately, it must be separate from everything else, right? It must be decoupled. But it's not. I've always really liked this poster for episode 1 with Anakin standing there and his shadow projected as Darth Vader. I've always thought this was incredibly clever because we know Anakin is Darth Vader or is going to become Darth Vader. But in this particular instance, in this moment, he is not. The logical Darth Vader is different from the physical Anakin at this point in time. So what I'm going to do now is I'm going to show you a technique that can make this previous situation a little bit better. I don't want you to go and apply this because you don't want to make things better. Also because it's not a golden hammer, it doesn't work in every scenario. So don't just go and say, William said apply this. It sometimes makes things better, sometimes it's not applicable. But it is a technique you can use to get rid of the distributed replication of data that you're going to build. So what we'll do is we'll replace our search service with a search engine, right? That sounds more natural, doesn't it? Search engine, search service, search engine. And what we're going to do is we're going to implement what's known as the engine pattern. So the engine pattern has some coupling in it, but not logical coupling or not business coupling. What do I mean by that? So the search engine will expose a contract that the other services must comply to. So they'll expose, for instance, 3 interfaces maybe. An iFindProduct interface, which given a text string will filter through a list of products and return them. We'll also have an interface for iPriceProducts. So for a particular user and a particular product, what discount percentage should they get? And we'll have a third interface for iTrackOrders, which just tells you, returns true or false, whether someone has ordered a product previously or not. The search engine takes these 3 interfaces, compiles them into a DLL, and hosts it on an internal NuGet feed or something like that. The product service, the customer service, and the order service can then download that NuGet package and implement whatever interfaces they want. So what I mean by that is that the product service can implement the product finder class. And the product finder class knows how to query the product service database. I hope it's clear that the product finder class sits squarely within the logical boundary of the product service. The customer service can do the same with a status pricer, and then the order service can do the same with a order history class. So all of these classes implement the interface that was exposed by the search engine, and they're currently sitting within the service boundaries that they're implemented in. And this is great. How do we wire this up together though? So what we can do is we can take the product finder class, compile it into its own assembly, and then take that assembly and stick it in the app folder of the search engine. And then when the search engine runs and it needs to do a search, it can ask .NET, hey .NET, give me all of the classes that implement iFindProducts. And .NET will go, oh, here's one, it's the product finder class. There you go. The search engine can invoke that product finder class, which will then go off and query the product database because it knows how to talk to its own database. And then we can do the same from the customer service. You can take the customer status pricer and compile that into a DLL, copy-paste that DLL into the search engine folder, and then the search engine can apply that to the products that it's got from the search result. And we can do the same with the order history one. We can track what the person has ordered before. How is this different from the previous one? We're still doing 3 sets of queries, right? Well, if the customer service changes the way that it does discounts and it goes away from status and changes over to ranking, the customer service deletes that status pricer and creates a new class, a ranking pricer, compiles that ranking pricer into a DLL and pastes the DLL into the search engine folder. Now the search engine, when it does a query and it tries to find all of the prices, the iPriceProduct instances, it doesn't have the status pricer anymore. It now gets the ranking pricer. The changes were constrained logically within the customer service. Physically, though, we deployed a different assembly into a different runtime, but that's not really a big problem. The interesting thing with this type of pattern is that you can apply things that seem like they come outside of that domain into different domains. So for instance, the product service could implement a daily pricer. Maybe every Monday, these products get a 50% discount. That can get put directly alongside the existing pricer. The same with the order service. It can create its own bulk history pricer, where if a customer over the lifetime of the customer's account has ordered 99 of these items, on the 100th item, they get a 99% discount. That can also just be deployed alongside. And all of that sits and resides logically within those individual service boundaries. Physically, we've deployed it somewhere else, but logically, it's separate. I always find it interesting that when people consider this type of idea, that it feels weird to them. Like we're putting these things together, we're coupling it, right? But this type of distinction between logical and physical is fine when you're talking about scaling out instances. We'll take the same code and run it in 2 places. That's also physical differences, but logically it's still the same thing. So don't do this. In fact, what you need to do is you need to make sure that you conflate your logical and your physical boundaries for everything that you do in your system. So a quick recap, what we've done is we put an HTTP call in front of everything. We made sure to attempt a big bang rewrite. Note I didn't say do. I did there. I shouldn't do that. Oops. We didn't use any off-the-shelf frameworks. We created a whole bunch of cool frameworks that we get joy out of. We then also made sure that we use nouns instead of verbs when defining our service boundaries. so that we can get the maximum chance of having cross-service communication. And in the places where we have cross-service communication, we made sure that we kept the logical and the deployment boundaries the same throughout the entire system. And if you follow these 5 techniques, you'll have a great time looking for a new job somewhere, I'm sure. I did say I would get you out of here a little bit early, and I'm pleased to say that I did that. If you have any questions, you can ask them now. Otherwise, you can also find me around NDC. I'll be here tomorrow and maybe a little bit later. I'm always excited to talk about writing bad systems. So if that's a common interest, we can write bad code together. But any questions? No? Okay, great. Thank you, everyone.